Hello everyone, I got a number of comments asking me to provide a simple game of JavaScript using Canvas. So here it is. In this game we have a hero, which is this guy on the left, and a bunch of enemies that we try to shoot them. We have a parallax background that is going like this, and if the enemy hits us, then we die. So for example, something like this, I'm hitting them, and let's hit this guy on the bottom, and then we die. Game over, score 11. So let's go and start writing the game. So here I have a bunch of images. As you can see, this is my sky. This is my hero. It has 15 different sprites. And then I have the enemy. It has 15 frames. And bullet, which has 9 frames. Okay, so let's go to the game. The first thing is that we need to create the canvas. So let's say now we grab the canvas. Let's give it some width and height. Is the width of the window. Same for the height. Great. And then we need to get the context. So let's say ctx is canvas dot get to the context. Get context. I'm not getting the methods for canvas, so let's first go here and type this at type HTML canvas element, and now if I say get context of 2D, I will get it. Great. Let's have some font as well here. So ctx.font is let's say bold 48 pixels and define it as serif. You can use any font that you like. So if I go back to my HTML, I have the style like this, removing all the margins, and I have the canvas here. So if I go here and refresh, and well, this is the canvas, the same size as the window. Okay, so when we want to animate something, we need to run basically a function for every frame of the animation. So we need to define a function. Let's call this function animate, and we need to run it repeatedly for every frame of the animation. So let's for now say that we want to clear the canvas. We use clear rect to clear a part of the canvas, but if we provide a 0, 0 for top left and canvas.width and canvas.height as the bottom right, then we get a full clearance. So if I clear this and say, for example, we want to type something, fill text, and say the word text, and let's say at 100 and 100. Now we need to call this function obviously, so animate. Now I get the text. Great, so my canvas is working. But as you can see, this function runs only once, so we need to call it for every frame. So there is a built-in function called request animation frame, which will call the function for after each animation. So we would provide the animate here, and it will be called for each animation. Now if I say, for example, log runs, and if I go here and refresh, and if I open my console, I can see that it runs for every frame. Okay, so let's get rid of this part and go and create our entities. So the first thing that I want to create is my hero. So for each of those entities I would have a class. So for example, let's say this is called hero, and this works as a blueprint to create objects from it. You will see in a second. We need to have a constructor for each of the classes that we create. This is mandatory and we need to provide it. And here we can define different properties of our hero, like its width, its height, its position on the screen, and so forth and so on. So let's begin with the width. Let's say the width should be like this much. If I zoom from here to here, so for every frame of the sprite, this is the width and this is the height. And I have calculated this. This is 200 for my image, and the height is basically 156. It might be different for your sprite. You can go and calculate it. And I need to have a position, so I would say x. I would call it 50. You can have it anywhere you want on the screen. And this dot y is like 100. And I have my hero here, so let's create one hero from the hero class. So new hero, like this. This will create a object based on this class with these properties. Now if I want to show, the convention is to have a show function here, show method here. You can call it display or whatever you like, but there should be a function here that takes care of drawing this hero on the screen. So for now, we just want to have a rectangle at this.x, this.y, with the height of with the width of this dot width and the height of this dot height. Great. Now I need to in the animate call this show method. So here I can say what was the name, hero dot show. Great. Now if I go back, you can see the rectangle is here based on the values that we provided. Great. But we need a image instead of a rectangle. So let's go and add the image to the hero. So this dot image is a new image, and then we need to provide the source. So this dot image dot src equals to they are in the same folder, so let's call this hero. And let me close this, by the way, make it a little bit bigger so it's more visible on smaller screen. So the name is dot slash and hero dot png. Great. Now we need to draw it. So let's say ctx. There is a function called draw image, and it has three different versions. The version 1 will get the image and the position that we want to draw it on the canvas. So let's say this.image is the image that we want to draw, and let's say draw it at 100 and 100. Now you can see that it draws all the sprite, but we only want one frame of it. So like this much width and this much height of the image we want to crop and display on the canvas. So as I said, there are three different versions of the draw method. We want the third one, which will receive 9 arguments. And what are those 9 arguments? Let me remove this so that this shows me the overloads. This one is what I want. I will provide the image, starting x and starting y, the width and the height. So these 4 values shows which part of the image should be cropped. So for example, if I want to crop this much, I need to provide those values. Sx would be like here, Sy would be like this much, and then the width and the height that I want. And then the other four are the destination x, destination y, destination width, and destination height. So where on the canvas destination x and destination y will say which point of the canvas we want to draw and how wide and how high we want to draw that image. So let me write it and you can understand it better. We want to draw the image. We want to draw it at, let's say, keep it simple, at 0 and 0. The width is the distance width that we defined, which is 200, which again is from here to here. Then we want to have the this.height. We want to draw it at this.x, the position of the hero on the screen, this.y, and we want to draw this much, this.width and this.height of the image. So now if I go back, you can see that I get this frame. Now if I say, for example, like 100 here, it goes like 100 to the right, so it goes here. If I go here, it would crop from somewhere around here and 200 pixels. But I want in each frame to show one part, so I want to crop at first from here to here, then from here to here. So from 0 to 200, then from 200 to 400, 400 to 600, and so on. So for each frame I want to multiply this by a frame number. So let's define a frame number here that starts at 0, and each time we want to say this.frame times this.width. Now it shows frame 0. If I go and say frame 10, then it shows frame 10. Okay, so this tells us that in each animation loop that we have here, we need to update this frame value. So we will have a update function here, and we would add to the frame each time. And when this animate happens, we would do we would do show, and we would do update. And we usually do the update before the show. So let's go back, and you can see it for 14 seconds. You can see, oh, it goes very fast. So I'm going from 10, but if I go from 0, see, you can see it for one animation, and it goes like so my hero is like for 15 sprites, and when it gets here, then it would continue going to the right, but there is no image to show, so I need to bounce back to 0. So here in the update, I would need to say that this.frame is, if this.frame is the last frame, which is 14, go back to 0, otherwise go back to this.frame plus 1, and we need to remove this. Now you can see that it animates, nice and easy. We can remove this fill rect, but let me have it like stroke for now, because I want to use this rectangle later on for collision detection. So I have it like this. Great. Now we want to move it based on the position of the mouse. So for example, if the mouse goes here, this hero should go down to here as well. I don't care about the X position of the mouse for now. We're only moving it vertically. So let's go here. I need to have a event listener that listens to the mouse movement. So document dot add event listener that will listen for mouse move, and it will trigger a function, and that function will get an event as the input. And I think we can get the what can we get? The client Y. I think the thing that is client Y is the thing that we want. Client Y. Okay, let's go here, refresh, and yes, so this is the values that we want. So instead of doing it like this, I want to update the Y position of my hero. So I can say my hero, and let's say move is a function that we will write, and we want to move to this position. So we need to define it, of course, here with the hero. So let's say move. This will take a Y, and the only thing that we want to do is to say that this dot Y equals the Y that we get. Great, and we don't need to call it here in the animate because this is not related to animate. This is related to the mouse move. So now if I go here, you can see that this moves, but it's like a little bit offset. So if I go here, I cannot go anymore to the up, and this will go down to the bottom. So I need to offset it. So the top of my mouse is like in the middle of the image. So in order to do that, here in the, where is it here? In the Y, I need to say that this should be offset by the height of the hero that we have here times, let's say, 0.5. So offsetting it based on the half of the height of the hero. Now you can see that this is in the middle, and I can go up to here and down to here. Great. So this is what I want. Next step, let's go and create our enemy. I would grab this part because it's kind of similar with the enemy. Let's have another class called enemy, and this will have a constructor. The image is the enemy, and the width and the height of the enemy are like 250 by 200, a little bit bigger than our hero. So let's implement those 250 to 200, and the X is, I want it to come from right, so the X is canvas dot width, and the Y is a random position, so math dot floor of a random number, math dot random, this is dot random, and then let's say we want it based on the height of the canvas, so canvas dot height, and we need to offset it based on the height of this object that is being created, so it doesn't go off bound like to the up or to the down. So by this. Great, and of course we need to have a show function as well. So this show function, for now, let's say it will have a basically only a rectangle, so struct rectangle, and let's say this dot x minus 200, so it offsets to the left a little bit so we can see it, and then this dot y, and then this dot width, and this dot height. I need to create an enemy based on that. So here let's say our enemy is a new enemy, and of course we want to show it here. So here we need to show the enemy as well. And each time I refresh, you can see that I get a new enemy in new position. Great. Now I want this enemy that I have here on the right to be scaled based on a random number as well. So some of them are bigger and some of them are smaller. So here on the creation, I will have another variable. Let's call it scale. And this will be a value basically between 0.3 and 1. So I would say math dot random. So give me a random scale, and I don't want it to be very slow. So I will let's say add multiply it by 0.7 and then add 0.3 to it. So it will be between 0.3 to 1. Great, and I need to of course include it in the show function here and here so that it is drawn based on the scale that I have. So this dot scale. Now if I go back and refresh, you can see that every time I get a different size of enemy. Now let's go and add image to the enemy as well. So again we need to have an image which we have added beforehand, and then we need to have a draw image as well. So I need to close this one and say ctx dot draw image, and this will be something like the draw image that we have here. So I will grab this one and paste it here. Basically again this dot image, and let's say again 0 0, this dot width, this dot height, and then say this dot x minus 200, so it goes to the left a little bit, and the width and height that should be scaled by exactly this dot scale. Great, now if I go here, you can see that every time I get a different size of enemy. Great. Now we need to animate it. So let's go and do that. So here again we would need to have a frame that we have already defined. Great. And we need to have an update function. So update function. Let's say we want them to move like minus 3 pixels to the right each time. And again, the frame should be the same thing that we had there. So this dot frame, if the frame is for enemy is like (15) again. So if the frame is 14, because we are going from 0 to 14, go back to 0, otherwise add to the frame plus 1, and of course we need to include it here as well. So this dot width times scale, not scale, sorry, dot frame. Now I don't see it because I don't call the update function, so I need to go here and let's say enemy.update. So we update it here as well. So now we can see that the enemy is moving to the left, and each time a different enemy is moving to the left. Okay, but the only thing is that I don't want this to move in a straight line going from here to here, so I want it to go like up and down, up and down. So basically kind of a wave movement for it. So in order to do that, we need to use the sign function that will give us a value between -1 and 1 that we could include with the y value, and gives us a wave movement, so to say. So let me write it and you can get it better. So here in the update function, so we can update the y value as well, so goes up and down. And let's say this is basically adds to a sine function of some angle here. So we need to have an angle. So let's say this dot angle is like 0. And this sine function basically works with radians, not degrees. So we need to provide a radian value here. So it gives us a value between -1 and 1. But the angle is between 0 and, but the angle is like in degrees, so we need to convert it. So we need to say this dot angle, the angle that we have here, times the pi value, and then divided by 180. So this will update our y, but we haven't updated the angle itself. So the angle also needs to be like, let's say, added 3 degrees each time. So if I go back here and refresh, you can see that there is a movement here that is for our enemy here. We can make it bigger or smaller by, for example, providing a value here like 2 times this value, and this moves way to the up and down. It's basically what you like. I'm happy with this one. And we can limit this angle between 0 and 360. So instead of adding 3 to it each times, we say that this dot angle plus 3. This is basically the same thing, and then we get the remainder of that value dividing by 360. So when it gets over 360, so for example this is like 359 plus 3, it would be 362, and then we divide it by 360 and we get to 2, and then we continue on. So basically we are removing this 360 from it. Okay, so this should work the same. Let me see again. Yes, working the same. Great. And I can remove this 200 from here as well. This is not needed anymore. So like this, and let me do the same thing here as well. Great. So this is working. Perfect. Now let's have like more of the enemies instead of only one enemy, which makes the game boring. So in order to do that, I need to have a array of the enemies, and after some time I need to add one enemy to that list. So let me do it like this. Instead of having the new enemy like this, I can say this is enemies and this is an array. And so these two obviously won't work because there is no enemy here, but I need to say after a certain time add one enemy to the list of the enemies. So I need to have two different variables here. One keeping the game frame or the timer of the game so that we know when to add a new enemy, and the other one is the frequency of the enemy to be created. So for example, I want after 120 frames one enemy to be added. So I need to know this value. Then I need to keep track of the game frame. So game frame is 1, then 0, then 1, then 2, then 3, and all the way down to 120. So I need to keep these two values. So let's say one of them is the game frame. So let game frame this starts at 0, and then I have another one, say new enemy frequency. This is, let's say, 120. Great. And this is let. I've defined these two as let this because this will be added as time goes on, and this one we might make it like less so that the games get harder and the enemies are created faster and faster. So these two values I have, and each time the animate happens I need to add to the game frame, obviously. So game frame need to be added, and just like we have it here, we need to keep it between 0 and 120 that we want. So we don't want it to go like beyond the values that we want. So here I can say the game frame is the math dot floor of game frame plus 1. So we get the game frame, we add 1 to it, and then we get the remainder of that value base divided by new enemy frequency. Same logic that we provided here for the angle works here for the game frame. And now we can say that, for example, if the game frame is 0 or 1, then add 1 enemy. So which means that we have gone 1 loop to the enemy frequency and we are back. So if game frame is, let's say, 1, then add 1 enemy. So enemies dot push a new enemy, just like that. And then here, when we want to animate, we need to go through the list of enemies and display each of them here. So enemies dot for each of the enemies, for each enemy call these two functions. Now if I go back and I'm lucky, I won't get any error, and yes, after like 120 I get a new enemy, and this goes on and on and on. Fantastic. Okay, but there is one thing here, and as you can see they all go up and down in the same routine. So I want them, one for example goes up and the other one goes down, so different waves, so to say. So in order to do that, we can go to where we create the enemy here, and instead of hard coding the value of 0, we can give it a random angle. So let's say math.random times 180. Now if I refresh, so one is going up and the other one is moving, so they move differently. So this goes up, this goes down, this goes up, this goes down, and this is great. Fantastic. So let's go to the next part. Okay, so for the next part we want to have the bullets or the things that this hero fires, because as you can see there are lots of enemies coming to him and he cannot do anything just yet. So let's go and create a bullet class of, let's say, bullet like this. And as you know what's going on, so let me grab the everything that I have here for the enemy and have it for the bullet as well, and then we update this because we know that the bullet will have a constructor. It needs to be updated and it needs to be shown. So what does our bullet have? Our bullet will have the image, of course, and the image is the bullet. It will have a width and height. The width and height are for the bullet. I want just to show this frame in the beginning, and then when it blasts I want to show the rest, so only this one, and this is like 100 by 100, this part. So I would say that the x and y and width and height are all 100 for this one. We don't have any scale for this. But for now I don't have any frame or angle for this. But the other thing that I want is that when it moves, it doesn't move in a straight line. So I can have two other properties for this. Let's call one x speed. Basically I'm providing this so that you can use them and change my code to the better. So, and this is y speed. And then when I want to update it, I want the x to be updated based on the x speed. So here this dot x speed should be multiplied by any values that you like, but I would just add a very small value here like this. And I want to y to get a little bit bigger, so this drops down, the bullet drops down. So I can say this dot y speed is getting a little bit bigger, so let's say 1.1 for now. And I want the x to be added like 4 each times. I don't have the angle, so let's remove this. I don't have the frame for now, and I want the y to be added like 0.5 each time. Great, and we can change these values, of course. And on the show, let's remove this one and say we want to draw an image, and let's say from 100 and 100, this dot width and this dot height, and the rest is the same, x, y, width. There is no scale here, of course, and this. So I have the blueprint for my bullet. I need to create it. So here, just like the enemies, because we don't know how many bullets will be there, I will have a array of bullets, and as we update the enemies, we update the bullets as well. So we can say let's first update the bullets and then update the enemy. So this enemy can be now bullet. Okay, but we haven't created any bullet yet. Let's say that when we click on the mouse, we want a bullet to appear on the here and then moves. So we need to have another event listener. Let's say document dot add event listener and then mouse up, and it will get an E again, and it will call a function. What we want to do is to add a bullet to the bullets list. So bullets dot push a new bullet like this. Now let's see what we did. Yeah, as you can see, each time that I click, a new bullet is created here and moves to the right. It's moving way too slow, so let me go here and make these values a bit different. Let's make this way too smaller, and let's say this is like 10. Now this makes much more sense. Great. But this shouldn't start from here. This should start from the position of the hero, so to say. So here, instead of saying new bullet at any place that you want, we would want it to be created on the position of the hero. So when we click, we want to get the position of the hero and give it to the new bullet. So we can say hero dot, let's say have a function here. I don't want to, grab this dot x and this dot y from the hero. Where is my hero? So here. So I don't want to access them from here. So I would define a method for hero that method will access those values. So I would say get hero lib position, and whatever that value returns, I would add it to the new bullet. So let's go to the hero and define that function that we just wrote. Get hero lib position. The thing this returns is the position of the lib of the hero. So basically it returns a x and y, so it's an object with the x being this dot x. So the position of my hero is the x plus the width, this dot x plus this dot width, and the y position of the lib of the hero is this dot y plus this dot height, and use it for the x and y here. So now if I go here and refresh and click, you can see that it works perfect. Fantastic. Okay, what do we need to do next? I want to remove the bullets as they go out of the bounds here. So because when I am clicking and they go out of the screen, I don't need to use them anymore. So this bullets array, I don't want the bullets array to get longer and longer and longer. So I will define something called is it removable or not. So removable, like so, is in the beginning false, and then when the bullet hits the edge of the canvas, I would just mark this as true, and on the update I would check and see if that's true, and then I will remove it. So here on the update I can say that if this dot x is greater than canvas dot width, which means it has passed the screen, set this dot removable to true, which means that we can remove it. Now where can I do the removing? Well, not here in the object, in the class itself, but here in the animate when I'm doing the animation. So here, before I do anything with the bullets, I need to remove the bullets that are marked as removable. So I would set bullets is the bullets dot filter, and let's say I get a bullet, and I would check to see if that bullet is removable or not. So bullet dot removable. If it's not removable, then keep it. If it's removable, don't remove it from the bullets array. This way we are updating all the bullets at the same time. So if, for example, in a scenario 2 or 3 of them in a frame leave the canvas, then we can remove them all together. Now if I go here and say log bullets dot length, Let's see what happens. I'm getting an error on line 138. Yeah, so these two, because I'm going to update them, need to be let. So you can see I have no bullets, then I fire a bunch of bullets, 9, 8, 7, and all of them leave the board. Great. I need to do the same thing with the enemies as well, so that when they leave the board, they need to be removed. So here on the enemy itself, I need to have another property, say removable, and this is in the beginning false. And the same thing with the bullet. If this leaves the screen, so if this dot x plus this dot width times the scale that it has are less than 0, then this dot removable is true. So basically I'm saying if the x, so suppose this is the enemy, if the x position plus the width, and they have a scale, so width times the scale plus the x, if this value is less than 0, which means that the left edge of this enemy has left the screen, then I need to remove it. And then again here, the same thing that happened with the bullets will happen with the enemies. So again, enemies is the enemies, and then filter each enemy where the enemy is not removable. Now if I log it here as well, so enemies dot length 01, 02, 03, I fire a bunch of bullets, 5, 4, you can see they get added and deleted, the enemies. Great. Now let's implement the collision detection, or basically hitting the enemies with the bullets. So if I fire a bullet, in each frame I need to see that has that bullet been colliding with one of the enemies or not. If it has, then we need to remove both the bullet and the enemy from the screen, because I don't want the bullet to go and hit this one and then hit this one and then, for example, hit this one. So hits only once. So how can we do that? We can here in the hit say that for all the enemies that we have, check that the enemy is colliding with our current bullet or not. Do that, we can do it basically by doing a big if statement here. So in order to better understand it, I would provide a sample here. So the hitting has not happened here yet, because the x value of the bullet that we have plus the width of the bullet that we have is less than the x value of this enemy. So we are here, but we have like this much space between ourselves and the enemy. So the hitting has not happened. Same thing here. If the x of our bullet is greater than the x of the enemy plus the width, so the enemy is here but we are here, so we haven't hit it. There is no way we have hit it. The same thing goes for y here and here. So if we are not in any of these four scenarios, then we are doing a hit, obviously. So we can say that if not any of these things that I'm saying, enemy.x plus enemy dot width is less than this dot x, or three other scenarios. So I would copy paste this part and all of them are or enemy x is greater than this dot width plus this dot x, and if enemy y plus enemy height is less than this dot y, or this is y, or enemy dot y plus enemy dot y is greater than enemy dot height, sorry, this dot height plus this dot y. So if this is not the case, then we can say hit. Let's go and see. Go here, check. Let me remove this other console log that we have here. Now, no hit, no hit. Okay, I didn't call the hit function. So here on the animate, for each of the bullet, I need to say that bullet dot hit the enemies or not. Now let's go and try to hit. You can see that it hits like 27 times, but after the first time we need to stop and don't do it. So now if you look at this, this will hit all of these 4 enemies. So what happens when it hits? It needs to be removed. So when this happens, we can say this dot removable is true, and we need to say the enemy that we are working on needs to be removed as well. So we call the function on that one instead of updating it from here. So we need to call a function on the enemy that will do the remove. So let's say remove. This is basically just this function that we have here, and I would say this dot remove here instead, so that I don't update the properties of the enemy from inside the bullet. Okay, so let's go and see what happens if I shoot. Yes, you see it disappears. Great. So we're hitting the enemies. Fantastic. Let me see a scenario which I have 2 enemies in one line, like this, like this. So this hits this, but this is still alive. Great. Now let's do the blasting, or this thing that we have here. So when we hit the enemy, we want these animations to happen before we remove the bullet, so to say. So let's go to the, of course, the bullet. Let's say I would have a flag called blasting. This, of course, at first is false because we haven't hit, but when we hit, we need to set this flag to true. And now we need to have the frame here as well because we want to animate it. And there is one more, which is the size of the frame, which is 300. Because as you see, we have created the bullet with X and Y and use it here with the width and height of 100, but the bullet that we have. So this one is 100 and 100, but these frames are like 300. So we need to have a 300 by 300 frame when we do the blasting. So here, when the frame size is 300, then when we do the heating, we don't want to do the removing on ourselves yet. We want to set the blasting to true. Let's say blasting, this is true. And then we want to return, so we don't want to check any other enemies. So now if I do the thing, you can see that it still goes because I removed the removing from here. I just set the blasting to true. And now I need to do one more thing. I need to say if the blasting is happening on the update, then don't do this, don't update it, just do the blasting, otherwise go on. So this is if not this dot blasting, then continue as usual as it was. So like this. Now it works the same again. See, it's still here and it still hits the other enemies. So I need to blast it now. Otherwise we need to animate it. So this dot frame plus plus goes to the next frame and goes to the next frame, so that these are shown. And then here on the show again, we need to say if not blasting. Great, I get this as well. So if not blasting, draw this image, otherwise draw the other image, which includes the like 300 value for the frame size and then each of these frames. So let me grab this and update it. So again I'm having this dot image. Now this time the value is 300, so 300 times this dot frame. So we go from 0, 1, 2 and so on. The crop y is like 0 because we want to crop from here, for example, to here. So this is 0. The value is was it this dot width and this dot height? No, it's like 300 by 300 if I'm not mistaken. No, 300 by 280. So 300 and 280, 88 actually. This dot x, this dot y, and the size that we want this to be is 300 and 288. And when the blasting happens and we get to the end sprite, so for example 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we get to frame 10, we need to remove the bullet. So we get to here and then we need to remove it. So here again I would say that if this dot frame is greater than 10, which means the animation is done and we are done with the bullet, then we need to remove it. So this dot removable is true. Fantastic. Now let's see what happens. Boom, boom, boom. Great, fantastic. I'm not happy with these values, so let me update this. I would have this dot frame size x is like 300 and then frame size y is 288. I don't need this one. So let me see if I'm using it anywhere. No. So these two values, and here when I'm doing the update, these 300 values will be this dot frame size x, and these two values will be this dot frame size y. Fantastic. So when I hit, yeah, it works. So let's get something with this text that we have here to show our score instead. So let me close these ones to get me more room. Here I would have another variable. Let's call it score, and in the beginning our score is 0. And when we hit an enemy, then we need to add our score. So in the bullet, when we hit the enemy, we can say score is plus plus. So you can add 10 to your score. It really doesn't matter that much. And here when we write field text, we can say instead score and then plus the score. So score is 0. Let me do it like this. Now I hit 3, 4, 5 and so on. Great. Now let's write the part when the game is finished. So basically, when any of these enemies hit our hero, the game should be finished. So again, something like that we had here for the enemies, we need to have for the hero as well. So hero, on the update, we need to check the enemies. If each of the enemies hit our hero, then the only thing that we need to say that the game is over. So we need to say the game over is true. Of course, we need to define it somewhere down here. So let game over be false. And when the game overs, we need to stop the animation. So here I would say if not game over, then do the animation. So if I go back, I hit a bunch of them, and then let's lose when this gets to here. Great, so now the game stopped and basically the game is over. So let's show something that the game is over. Here when the if happens, then there needs to be an else that shows the game is over. So here I just say that align the text on the center of the place that I want to write, so like this, and let's have a rectangle. So we do a clear rectangle of some part of the screen. I have it like this. You can write anywhere you like. So I would say width divided by 4 and height divided by 10. So on the top up to canvas dot width divided by 2. So basically half of the width from 4 to 2. And let's say canvas dot height divided by 5. Clear this part and then write something. Write ctx dot give me a text of game over on the canvas dot width divided by 2 and canvas dot let's say height divided by 7. Okay, now let's go and lose and see what happens. Okay, I get this. Great. I need to have a border around this. So let's, when they have the clear rect, have a stroke rectangle here as well with the same values and see. Okay, game over. Great. Now let's write the uh, score of the user as well. Score is plus the score, and let's say this is at here, and let's have it like 100 pixels offset. Great, so we have it like this. Okay, fantastic. Now the last part is to add the background, which will move from the right to the left. So for that one, I will also include another class. It will have a constructor, of course. This.x is 0, this.y is also 0. It has an image, which is a image, and the source is like dot sky, yes, dot slash sky dot jpg, and I want this sky, so it goes from here to here and then from here to here. So when this moves and gets to here, then I need to reset. So when the animation starts from here and it shows like this part and it goes down to here, I want to reset it and then start from here again. So I don't want this to, go off the screen. So I would need to have a width, which for me is basically half of the width of the sky that I have here. Then of course I need to have two methods, one update and the other one is show. The update is basically just checking if the x is less than this value. Basically this is 2140. So if x is less than this value, I need to reset it to 0. So this.x, if this is less than minus 2140, then set the x to 0. Otherwise, let's say minus 3. And on the show, we need to just draw it. ctx.draw image. This image at this.x and 0. So the thing that happens now is that I don't get a background because I didn't add it. So I need to go and say here, for example, let's say here, new bg, and on the animate we need to include it. So when we clear the rectangle, we need to say update the background and show it. So it should be before any of the other, so that they be written on top of the background. So now I'm getting my background as well. And my game is basically complete. The only thing that is remaining for me is just to remove these rectangles around these entities. So for hero, when we show, we need to remove this one, and for enemy as well, we need to remove this one. Great, now I have a complete game that I can play. Later on, you can check for score, and if it gets bigger than a value, then make the game go faster or provide more enemies by making this value smaller and smaller. But I want to just pause this video at this moment because it has gone way longer than I would expect. So the code to this game is on my GitHub channel, and the link is in the description as always. If you liked the video, please provide a like, comment, or even subscribe to my channel. And if you have any suggestions, comments, please don't hesitate to write a comment. Thank you for watching, and see you in the next video.